magnetic field due to a current element. Biot-Savart law. So what is Biot-Savart law? We know moving charges or current produces magnetic field. The relation between current and magnetic field is given by Biot-Savart law. Let xy be a finite conductor carrying current I. Consider an infinite small current element dl. So current passing through this infinite small element dl is equal to I dl. We have to find out the magnetic field at a point P, which is situated at a distance r from the current element dl. Suppose the magnetic field at the point P is equal to dB. According to Biot-Savart law, the magnitude of magnetic field at P, that is dB, is proportional to the current flowing through the conductor I. dB also proportional to the small element dl and is proportional to 1 by r square. So the magnetic field at P, that is dB, proportional to the current I, proportional to the small element, infinite small element dl, proportional to 1 by r square. And the direction of the magnetic field is perpendicular to the plane containing dl and r. The sense of dl cross r is given by right hand screw rule. If you move from dl to r anticlockwise, the direction of dB is upward or towards u, which is denoted by dot symbol. If you move from dl to r clockwise, the direction of dB is downward. It is represented by cross, or it is called away from you. So in this figure you see what will be the direction of dB. The direction of dB is perpendicular to the plane containing dl and r. If dl and r in xy plane, then dB will be along the z axis. Then the dl cross r, how to find out dl cross r? The sense of dl cross r is given by right hand screw rule. Remember, the sense of dl cross r is given by right hand screw rule. If you move from dl to r, here it is moved from dl to r, but it is in clockwise direction. If movement is in anti-clockwise direction like this, then the direction of dB is upward. You should have a here dot. But if the direction of dl from dl to r is clockwise direction, then it is represented by cross. Here it is represented by cross or inward, or you may say downward, or you may say away from you. So the magnetic field dB will be proportional to I dl cross r divided by rq, or that will be equal to, dB will be equal to mu 0 by 4 pi I dl cross r divided by rq, where mu 0 by 4 pi is a constant of proportionality. The above equation holds when the medium in vacuum. When the medium is vacuum, then you multiply mu 0 by 4 pi here. Then what will be the magnitude of the magnetic field? the magnitude of the magnetic field dB magnitude will be equal to mu 0 by 4 pi I dl sin theta divided by r square, because vector r, here vector r will be equal to magnitude of vector r into r cap, and r will cancel, one r will be cancelled, so it will be equal to I dl divided by r square, and for cross product it will be equal to I dl sin theta divided by r square. The value of mu 0 by 4 pi in SI unit will be equal to 10 to the power minus 7 Tesla meter per ampere. Here mu 0 is called permeability of free space or vacuum. Now let us discuss what are the similarities between Biot-Savart law and Coulomb's law. Both are long range forces, since both depend inversely on the square of the distance from the source to the point of interest. In Coulomb's law, we have F proportional to 1 by r square, and in Biot-Savart law, the magnetic field is proportional to 1 by r square. So both are long range forces, and both depends upon inversely, both depends inversely as the square of distance. Then number 2, the principle of superposition is applied in both fields. In case of Coulomb field, we apply the principle of superposition. In case of Biot-Savart law, for the magnetic field, we also apply the principle of superposition. Now let us discuss what are the differences between Biot-Savart law and Coulomb's law. In Coulomb's law, the electric field or the electrostatic field is produced by a scalar source. The scalar source is nothing but the electric charge. In Biot-Savart law, the magnetic field is produced by a vector source, which is nothing but I dl. In Coulomb's law, the electric field is along the displacement vector joining the source and the field point, and in Biot-Savart law, the magnetic field is perpendicular to the plane containing the displacement vector r and the current element I dl. In Coulomb's law, there is no angle dependence. In Biot-Savart law, there is an angle dependence. In Biot-Savart law, the magnetic field at any point in the direction of dl is equal to 0. You see in this figure, the magnetic field at any point here in this line will be equal to 0, because in this case, for any point in here in this line, theta will be equal to 0 degree, and if theta is equal to 0 degree, sin 0 is equal to 0, so magnetic field at any point in this line will be equal to 0. Now let us work out a problem. An element delta L is equal to delta x into I cap is placed at the origin and carries a large current I is equal to 10 ampere. Suppose this is the element delta x, and it carries a current given 10 ampere. What is the magnetic field on the y-axis at a distance of 0.5 meter? So you have to find out the magnetic field here, which is at a distance of 0.5 meter, and it is given delta x is equal to 1 centimeter. We know the magnitude of the magnetic field dB is equal to mu 0 by 4 pi I dl sin theta by r square, and dl value is given 10 to the minus 2 meter, I is given 10 ampere, r is given 0.5 meter. We have to find out the value of dB. Since theta here is equal to 90 degree, so putting these values you can get dB is equal to 4 into 10 to the minus 8 Tesla. Now what will be the direction of the magnetic field? Here dl cross r, here dl is given along x axis, So delta x into I cap and r is given along y axis. So y into j cap. So if you take the cross product of I and j, then it will be along the k cap. So it is along the positive z axis direction. The direction of dB will be along positive z axis direction and it is upward. So you see in the figure, it is represented by a dot. That means the direction of the magnetic field is along the positive direction of the z axis. And if you note the magnitude of the field, it is of the order of 10 to the minus 8 Tesla. That means the magnitude of the field is very small. That means if you give a very large amount of current of the order of 10 ampere, then at a distance 0.5 meter, which is very small distance from this current, the magnitude of the magnetic field produced is a very small value.